All right, AI and networking is all the rage right now. I'm here at Juniper talking with my new friend,
Kyle Baxter.
Kyle. Who are you? What do you do?
So I head up our Apstra product team, which is our data center control point for managing, operating, and assuring our data center networks. I've been at Juniper now a little over 3.5 years, and loving every moment of it, and loving what we're doing to truly revolutionize what data center operation means and how we can bring AI to the operator's day-to-day life.
So AI is it's obviously the thing everyone's talking about.
Oh yes.
And I know that Juniper's doing a lot to bring AI to the data center. The first question I have though is that, again, everyone's kind of doing AI. What is so different about Juniper's approach?
Yeah.
Because I know it's a bit different.
Yeah, absolutely. We take a completely different approach, and we've been doing this for over 10 years. And this started with Apstra, which was a startup that was founded on the principles of intent-based networking.
Okay.
And what intent-based networking allows operators to do is to look at networks a little bit different. So instead of configuring the CLI switch by switch, we're looking at it holistically as a system on what is the outcomes you want to achieve.
Okay.
Because while the CLI is important, what you're truly offering in a data center is applications. And you want those applications to work 100% of the time. And so with intent-based networking, where we truly differentiate from users is the ability to provide context to that data. And that's what we get with our intent-based design, is that context. And so others out there, they can provide you tons and tons of data, and they may be trying to slap AI on top, but without real information, real data and context of what that data is, AI can only do so much. Like, it's great, but without knowing what it's looking at and talking about, it doesn't do anything, or it hallucinates.
You're exactly right. And that's what I tell people when I teach AI. I'm like, it's all about the quality of your data.
Yes.
Feed it the right things, start out with that. Like 90% of your work is clean, good data, and then you'll have a good time. Otherwise, you'll spend half your time like, no, I meant this. No, I meant this. You're an idiot. Like, no, you didn't teach it right.
Yeah.
So how did you guys teach the AI to just know, like, how did you, because I know we're dealing with like CLIs before, and we've evolved to where we are now with intent-based networking. What is that, like, what are the components we have now with your AI infrastructure? Like, what does it look like?
Yeah.
What are the components that make up this new thing you guys are doing?
So it starts at the core of what Apstra brings, which is a graph database. And it truly brings that context of data that we can use to then train AI for. And so what that looks like is, and why that's important, is everybody else out there will dump a bunch of data, and then you're trying to look at it and figure out what is related to what. An example here is like a scatter plot of a bunch of data. If I told you to look at this and figure out what this was, eventually you might figure it out.
Yeah.
But you're going to have to look through, like in a network where you're going to look through traces and logs and SNMP traps and anything else on all this data that you're having to look through and figure out what it means. But with Apstra and our graph database, we know the context. We know that it's not just a scatter plot, but it's a cat. We know exactly what the data is, and funny jokes aside, but we have that actually in the product.
Okay.
And so here we're looking at what our graph database looks like in a real network, where we've modeled everything that you have in a network, from the virtual and the physical elements. So things like the switches and the IP addresses and links and interfaces and the virtual networks, the VXLANs, VTEPs, VNIs, anything in all those acronyms that are out there in the networking world. We've modeled all of that and how they relate to each other to be able to provide that rich data and rich context.
Okay, so it's basically like, I know up until now we've built networks for humans to be able to understand and interact with them. It sounds like you've now rearranged it to where a machine can then better understand it versus humans.
Yes. But before really AI became popular, like you said, we designed this for humans to be able to use it. It just now is a byproduct that we can now take that and be able to give that to AI and easily be able to train that. And so what we're doing is taking the best of what we've had with Apstra, which is that contextualized information in that graph database and the relationship, and we're now bringing what we've had for 10 years with Mist in the AI that they have in the campus and branch to bring that to the data center.
Now, real quick, sir, for my audience that doesn't know what Mist is, what is Mist? Because I know Juniper's been doing this for a while, but many people may not even know this is a thing. So what is Mist exactly?
So Mist is our control point for campus and branch deployment. So think of like your wireless in your campuses. And so it is a cloud-based offering, and it provides rich AI features. So it's been trained for 10 years on how to take network information and be able to bring AI insights to it. And so it was founded by some really smart people in the industry to be able to take that information and bring it as a solution. It truly differentiates from what anybody else can do in the networking world. And now that we can take that and we can now extend that to not just the campus, where your wired and wireless, access points are, but to your data center, to your core network. And we're also bringing that to the LAN.
So I have to ask though, like you say 10 years. Was it called AI 10 years ago, or did we say machine learning? Because like that word, we've had to change our marketing when we say that. So was it called machine learning back then, or how did we change that vernacular when it got to like now?
I think they've always called it AI, but there was some machine learning elements to it. And obviously with where the world has evolved, we're latching onto that term, but we've been calling it AI ops before, before AI blew up a couple of years ago with ChatGPT and everything else that we can do now with AI.
Okay. Yeah, I was just curious because I know you guys have been doing it for a while, but it's only until recently we're like, oh, AI is a thing, and now we have it baked into every single buzzword we have.
Yes.
So yeah, let's keep breaking down exactly what this thing is. So now we're moving it to the data center side. It's already existed in the campus and the wireless. We're going to bring that magic to data center.
Yes.
Now, why is that such a big deal? Like, why do we need that at the data center?
Well, users struggle with how do they manage data center networks. Data center networks are usually complex, they're large, they have very specific needs, and like I said in the beginning, you want to be able to provide that 100% uptime for your applications. And when things go wrong, who gets blamed first?
Yeah, it's the network.
The network.
Yeah, every single time. Or DNS.
It's always DNS.
It's always DNS.
Yeah. But the network team gets blamed first. And so teams are struggling with how do they have insights into that data? How do they reliably make changes? How do they have that confidence that they know it's going to work? And that's what we can do with Apstra and combining the Mist AI and Marvis AI capabilities, is we can provide that confidence, that insights, because we already have very enriched data that we can then now apply confidence to that data. We can then get to things like, how do we automatically fix it? How do we recommend? How do we predict when something's going to go wrong to even prevent an issue in the future?
See, that's a wild aspect, prediction. How does that work? I mean, obviously you're going to have a lot of telemetry coming in, and you have your data. It's called the data graph, right?
Yeah, graph database. Yep.
Oh, the graph database. How is it able to predict? How does that work?
Yeah. So we have enriched data that we talked about from the graph database that has all the relationship and the context information of it. So what we can do is we can take that history of information and be able to look at trends. So let's take an example of a common data center issue, an optic failure. So we've looked around, and what we see is somewhere about 1 to 3% of your optics are going to fail every year.
Yes.
1 to 3%. Well, that's a small number. That's very impactful for a data center that's trying to provide 5 nines or however many nines of reliability you want to be able to provide, which means like minutes of downtime, which you can't have that.
Right, no, you cannot.
If 3% of your optics are failing all the time, you're just running around fixing optics.
Right.
But we can look at the data we have for things like temperature and bias and voltage and all the information we can get on the optics, which we already get and we already know, and we can start looking at trend analysis. And that's where AI and machine learning models come into play, where we can start looking at that historical trend to predict with a level of confidence that this optic is going to fail in a couple of weeks. You need to order a part now and have it ready to replace before it goes bad and impacts your applications that you are providing as a service.
I tell you what, I would have needed that right before this trip. I'm telling you, like 3 seconds before I walked out the door to catch my flight, both my power supplies and my servers died.
Yes.
And I had no way of fixing it. I just had to leave. I would have loved a little warning, like, hello, your stuff's about to die. So that's what we're kind of seeing, like just that predictive analysis. We're removing downtime as much as we can. Almost, I mean, if you can predict anything, then you don't have to worry about downtime.
Yes.
Now, I know we can jump into other stuff, but I'm curious with the LLMs that we're using, what is Apstra using for the LLM? Or do we have options?
We have options. That's the good news. So with our Marvis AI assistant, we have our own LLM that we have trained that we can use as well. And this is via our cloud service that we can offer. And it can not only search the database of information we have on our public docs, just like all other LLMs can search.
Right.
But we're also bringing in this year the ability to search into that rich context of data I was talking about in the graph database, to be able to add that into your troubleshooting, to be able to add that in a conversational nature that you can look at and use to help you be able to understand what's going on in your network. You can ask it things like, what applications do I have running through that port or that interface?
Oh, wow.
You can ask, how many more IP addresses do I have in my IP pool? Give me an inventory and format it in this way or that way. You can get really creative and be able to have it generate, on-demand reports based on what you have in your actual running network.
Okay, so on-demand reports, describe that. So like I'm talking to it, I'm like, give me a report on how much downtime we've had in the past 4 months. Could it do that?
Yes.
What would that look like? Did it just spit out like an Excel spreadsheet, or what does it look like?
Whatever you want it to.
Oh, okay.
Your imagination is the limit.
Okay, all right.
And because LLMs can spit out. You want it in Excel format? Sure. You want it to create a PowerPoint slide? Dump right in a PowerPoint.
Just
slide.
and it makes that sound too.
Yes. Yeah, exactly.
Multimodal.
Yes. Exactly.
Very good. Okay, so the LLM. I'm curious about the fine tuning. How did you guys fine tune Marvis? On what data?
Yes.
Yeah.
So we have customers using it today, and we also have Juniper IT. So our own IT organization is our customer zero.
Okay.
And so they're always, we're always pushing them new stuff, new capabilities. They're trying it out, giving us feedback. We can get the data from there that we have, and we're seeing the results with Juniper IT and our several of our customers that are using it today. So it's a combination of training that we have from our own usage in our own labs, as well as using desensitized customer data.
Right, yeah. I would imagine there's some sensitive stuff, but you to clean it up and hand it
Yes.
off. Now, we're probably getting too in the weeds in the AI spot, but people love AI right now.
Of course.
How often are you retraining the model? How often are you fine tuning? Because I imagine things change. You get more and more data, more and more people use it. Do you have a cycle of retraining and fine tuning Marvis?
Yeah, it's a constant refinement that we're always looking for how do we improve and how do we improve that efficacy score. So every time we get used it, we look at the feedback, we then fine tune and keep improving the model. So it is a continuous improvement and evolution of how we can keep proving that every day.
Now I'm curious, what was the base model that you trained on? Or can y'all tell us that?
No.
It's a secret. Sorry.
Yeah. It's proprietary, but it is what we've built in-house in Juniper.
So then explain the bring your own LLM. How does that work?
Yeah.
Or can I? Is it anything? Can I bring Claude? Can I bring ChatGPT? Can I bring Gemini?
Yes.
Olama, or not Olama? The Llamas, the Llama 3s, Llama 7DB.
Yep. So you can bring those as well. So that use case is probably more for ones that are uber sensitive on their data. So think of like a federal government or maybe a banking financial institution that is very, very sensitive on their data, and that we're rightfully hesitant, even though we do secure our cloud just like everybody else does.
Yeah, they have regulations.
Yeah, but they have regulations.
Rules. Yeah.
And like the federal government, they might need FedRAMP authorized clouds and things like that. But they likely have their own LLM in-house that they brought in that's trained from a Llama, ChatGPT, whatever model that they can then bring in and use. All we need is where is it? Auth key, API key, those kinds of things where we can then be able to integrate that and bring their own LLM to the discussion.
How does that? So if I were to say, hey, I want to use my own LLM. I trained it on NetworkChuck data. It talks like me. It loves coffee, and it's running on my laptop. How do I connect it to your network per se? How would I do that? What does that look like? Is it just here's my my IP address with my APIs, and you just plug in? Is that it?
That's simply
That's it. Okay.
Yep.
Okay.
Yeah, it's very simple. Where is it located? What's the auth key to get in so we can authenticate with it? Just like you would for if you wanted to use any APIs from ChatGPT.
Okay.
Integrate with that, you need some kind of auth token and key, and same thing that we would use for bring your own LLM. It's a connector style that just needs authentication.
How does it? So I'm familiar with how we use agentic tools like MCP and you can plug in tools like that. How does it when I'm using Llama or ChatGPT? How does it discover that it can use Juniper tools?
Yeah. So similar to MCP kind of style, but we built it in-house in our own way where we can then be able to do what we call text to API to be able to convert the text that somebody's asking and the question they're asking into actual API queries. And so we have it mapped into all the different APIs we have within Apstra that can query that context of data we were talking about to be able to know which API. So if you're asking it about, how many IPs left do I have in my IP pool, it knows this is the APIs to go call, get that information out, and then it can use the LLM to then format it in whatever way you want that formatted result to return to.
That's pretty cool. Okay, so we can nerd out on that. We can go down a million different directions with that. Let's get back to the data center. So keep breaking down for me the different parts. And we can keep going through the slide deck here.
Yeah. So where we can use AI is in a couple different areas. And so we categorize it into a couple different areas. We're starting with detecting. So how do we detect where the issue is? How do we give you visibility in what's going on? And we do that with what we call application awareness, which can provide that true mapping of where your applications are routed through your network. So we can tell you have a MySQL database that is connected on this VM, on this host, that's connected to 5 different clients that are running through these these spine devices, and show you the traffic patterns, show you which interfaces and ports it's connected through.
How does it know that?
We can get all that from data we get on the switches.
Okay.
So things like flow data. So S-flow, NetFlow, those kinds of protocols. We can track that information on how it's flowing through the network, and then we can draw that path, and then we can get what's connected to what, because we can, in the flow data, you can see source and destination. And so we can make determination there. So that builds that real-time map of what's going on in your network.
Okay, and that map is that's the data graph we're talking about. It's filling up the context of that.
And so that's the foundation of what we get. So once we have that map, then we can start looking at how do we diagnose an issue. When something happens, what do we do? And so we can look at, when an issue happens, we can determine what is the root cause. Not just, bombard you with information that, hey, you got all these events, but here is your root cause that you have a link issue. And that link issue is causing, BGP sessions to be down, it's causing route tables to be missing, but you could troubleshoot those for hours and try to figure out what's going on.
Yeah, I mean, I remember, I've had those 3 a.m. calls and everyone's getting on a call all sleepy, I'm not even sure what's happening right now, and you're having to troubleshoot BGP. No one should be doing that. That's so dumb. I'm at my worst self trying to figure that out.
Yeah. And that's where this comes in play. We can use the AI to be able to detect what is the root cause. And then because we had that map, we know then, that we had this link issue, we know that there were these applications that were using that path and these clients that were accessing it, we know those are impacted. So then in that 3 a.m. call, you can be like,
what's wrong?
You can just ask it what's wrong, and it'd be like, here, you have a link issue, these are your impacted applications, you know who you gotta notify to be able to do that. And then the next stage is, how do you fix that? That's great that we detected what the root cause is, but ultimately you wanna go fix that. And that's where Marvis AI comes into play. And where we were talking about using the chatbot to help troubleshoot, we also have a feature called Marvis Actions that categorizes events and gives you recommended actions based on the data that we have from trained information that says, you have this kind of issue, we know what kind of signature it is, we know where you should go look at, and then you can use that chatbot to go even further to be able to query all right, so I know there's a link issue or whatever it is, I need to go troubleshoot this, ask the chatbot, and it can, using the documentation and everything else we have, hey, follow these steps to help you troubleshoot, give you step-by-step instructions.
And that documentation is based on Juniper best practice.
Exactly. Okay. Exactly, like our Juniper validated designs and everything we have published.
Now, so you said that you have actions and signatures. These are all things common things that you see might be an issue.
Yes.
And it's okay, we've seen this before, bam, come in. But what if it's something that's kind of unique to the environment? How will it do with something like that?
Yeah, well, we've trained this based on standards, and we push people to standards.
Okay.
And so Apstra is built on our reference designs, or our Juniper validated designs. And so because we're pushing people that way on standards-based deployments, we can help direct people that way. And we pick standards-based deployments because we know they're going to scale the best.
Yes.
And so we're pushing people to a data center to an EVPN VXLAN architecture with ERB and everything else that goes with that to get to that right scale. So we have context of what is being deployed. That gets back to our intent-based nature.
Right, okay.
Is because we know that you're pushing this kind of design, we have parameters that we can fence it in a way, and be able to know where we want to direct you.
Okay, so but if you do happen to go outside of the recommended design, which
Yes.
I've been there. You do it sometimes. It just kind of happens. A little fix here, a little
Yes.
fix there. Can Apstra have that context to be able to know, like, okay, there is something different here, and if something bad happens, we can look there and know. Can you provide it more context? Can it automatically learn that context?
So we do have that option. It's a deployment model we call freeform, which, as the name indicates,
You're going off the rails, buddy. This is freeform.
Yeah, it's totally freeform to build anything
Yeah.
you want for that exact use case.
Okay.
Now it limits a little bit of what you can do because the guardrails just went off.
Yes.
You can do anything you want. You want to design a ring network? Sure, go for it.
It's going to suck, but that's your choice.
But yes, you chose it, you can have it. But we
Yeah.
can still do things like look at your optics, your system health, and things like that. Obviously, we're not going to be able to assure you're doing BGP right, because you may not be doing BGP. but
Now,
there is some areas we can still provide some of that information.
Now, is it only Juniper devices, or could it be third party as well?
Great question. So Apstra is also built on a pillar of multi-vendor.
Okay.
So not only do we support Juniper devices, but we also support devices from Cisco, Arista, and devices that are Sonic based, which is the open source NOS that's out there that is gaining a lot of traction. So for whether it's Dell or other vendors that are using Sonic based devices, or that NOS, we can support those. So it is more than just Juniper.
Wow. So it's just they have their APIs, I imagine. You just tie it to those APIs.
Exactly.
Okay.
Exactly.
That's
and
cool.
then what we can do is Apstra normalizes that information. So that way, when we start doing AI to it, no matter if it's data from Arista or Cisco or Juniper, we've normalized that data in our graph database to show that relationship that it's just a switch in a network. No matter how you configure it or what the hardware is underneath, we then normalize that. So then the AI stuff on top can all work no matter what the underlying infrastructure is.
That's awesome. That's killer.
Yeah. And so where we're then taking it is then how do we help verify your services? We've detected, we've given you the map, we've root caused it, we've helped you fix it. How do we verify it? And that's what we call service level expectations.
So not SLA, SLE.
Yes.
Okay.
But it's similar to an SLA.
Right.
But it's your expectation on what has your services actually been. And so we can look at your past and be like, look at how many over a certain period of time, how many of those minutes were actually successful versus not, and give you a percentage score, and be able to then categorize where things are going awry, when things go awry, what is impacted.
I need that for my life.
I know, don't we?
We need SLEs for personal stuff.
Yeah. And then what really gets, I think really truly exciting is now that we've built all this information around the map and the root cause and being able to verify services is, we talked a little bit earlier about predicting and be able to predict, when the optic is going to go bad or when that power failure, that power supply is going to go bad.
Don't talk about that. It's a sensitive subject.
It's a little too sensitive, but
Too soon.
but we can look at that information and be able to predict when that's going to happen. So we could have told you a couple weeks ago that, hey, your power supply is going to fail before you go on that trip. You need to go get a spare
And I probably
one.
would have forgot to replace it, but at least I would have known it. I knew it was my fault.
Yes.
At least then.
You at least would have been warned.
Yes. Okay, cool. So what else do we have with it?
So where our ultimate vision is going is we want to get to self-driving. I know a lot of people, have hesitations of, oh, you're gonna self-drive my network, and what does that mean?
Yeah, like I'll let my Tesla drive itself. My network, I don't know about that. That's scarier.
Yeah,
That's more real life for me.
But because of what the foundation we built with Apstra here at Juniper is we built that reliability and that confidence that it's going to work. And we have that visibility that you could always go look and check to make sure it's still going the right direction.
Yes.
So that's where our ultimate vision is to get to at Juniper, is to have those self-driving networks, self-healing networks. So when there is something that we can go change and fix, think of like a security use case. You're getting a DDoS attack. Today we can detect that and tell you, hey, you're getting a DDoS attack from here on this interface, this port. You need to go do something.
Right.
What if we could just close that port and shut it down and solve it for you? And send you a notification.
Yeah, a little Slack message like, hey, by the way, we took care of that for you.
Yeah. And you didn't have to worry about that anymore. That's things where we want to get to, and how do we get to that area of self-driving nature? And that's obviously a long road of taking it, because we got to build that confidence.
Yes.
But we have that foundation in the right way with the right data that we can do that and provide that confidence that it will work.
Right. So I think, yeah, the journey we have now is people don't trust it just yet.
Yes.
But you're building the confidence by showing what's happening, and maybe even like, hey, this is how it might be fixed. Why don't you try it? You're like, well, you were actually right. Tell you what, next time I'll let you do it. That's kind of the confidence path we have here. Now, so when can we see that? Like, when is agentic AI or agentic ops, where it's going to fix things by itself? When do you think that'll happen?
I think we're close to it, and we'll get there. I'm not going to commit to any
right now on the table. I want to know.
but that is the direction we want to get to, and I think we're near that, and that possibilities are very close on what we can do. And obviously, we'll start with the right use cases.
Yes.
And be able to provide that confidence and instill that it's going to work. And it's not going to just mess up your production network. And ruin your
well. And one thing
weekend.
I was reading about this. One thing you guys have is the digital twin, which I think is amazing. Like, you have an exact copy of the network, and you can simulate changes. And I think that comes into play when you're doing the, hey, look at my stuff. Hey, let's make this change. It'll make sure, like, it even make sure you don't break things.
Yes.
So you're like, hey, that's a bad change. Please don't do that.
Exactly.
And that eliminates so many human errors. Which human errors are that's one of the biggest things in networking.
Yeah. But what we've heard from our customers is when they start using Apstra in our solutions, is they've eliminated human errors.
Oh, wow.
Not just reduced, eliminate.
That's crazy.
That's powerful. And where we want to get to is, how do we, just completely eliminate errors?
And completely eliminate humans.
Not yet.
Well, and that's actually, if we want to take a little dive there real quick.
Sure.
So with network engineers, obviously we're doing some amazing things to make our lives easier. And the stuff that we are not good at, like looking through 10,000 lines of logs to see like what's correlating with lots of data, AI is doing that for us. And that makes our lives easier, but as we keep going on, where you can look at the network, find the problem, and then fix it, and we're just the guy that goes, oh, cool, good job, buddy. Eventually, will it even need us to do that? What are we going to be doing? Like, what do you think the future of network engineers is going to look like? Let's say 5 years. Let's say you guys nail it, and I know you probably will. It's going to fix all the issues before even anybody blinks. What is the future for network engineers, do you think? And I know I'm asking you to go crystal ball here, but we know AI models are going to get better and better and better, and you're just going to bake that right in.
Exactly. I think it's going to be more of a tool that helps network operators be able to work faster and then up-level their skills and up-level their thinking. So they're no longer stuck in the CLI, debugging BGP like we were talking about, and trying to figure out what's going on. Now they can start looking at it, at a different level and at a bigger picture. And we're seeing this with our users. They're telling us that I can now look at my network differently as I'm delivering a service, not as I'm, delivering a CLI configuration on a switch, but I'm delivering a service. And so how do they start looking at how do they design a service, and then we're still going to need humans on where are we going? Where do we need to deploy more? What's the next application that we need to host as a user? So it's going to up level, I think, the thinking that we'll give to network operators. So it won't eliminate their jobs, but it'll up level their thinking, give them the tools to work faster, so they're not stuck day-to-day troubleshooting networking, but looking at how do they deliver a true service that hosts applications for their own users and their own business to solve business needs.
I like that. That's a good answer. And I love the optimistic side of that, because there's many people who will say like, we're done. Give us 5 years, we'll just be post-job economy. But I like that idea of like, it's freeing us up to be able to use the unique humanness that we are to figure out the big things. Find the big questions we're trying to answer, the big problems we're trying to solve. Let AI take care of all the groundwork. So let's say we have people watching this right now that are looking to jump into IT, let's say network engineering. What should they study right now? Because it's not going to be the same world you and I came up in. Like I was learning CLI. The CLI might not be a thing anymore. Like the CLI was built for you and me. We may just be interfacing with a chatbot, and we have to understand networking still, but we may not have to know CLI commands. So what should a new network engineer study right now?
Yeah, I mean, I think it's more what they can do with AI. You hear of like prompt engineering roles, popping up. And so it's learning that, but there's still a network concept you still have to know. Even our users, talk about they don't have to know the CLI commands anymore. They just have to know how to point and click a mouse.
Yes.
But there still is networking terms that you still have to know. Do you have to know, how to configure BGP? No. But you still need to know what it means, how it works. And so there is still concepts that I think are useful to learn. But then how does an AI play into that? And how do you use AI? So there's still, aspects there that need to know. And then, still I think we're going to still need programmers and developers. And I think we're seeing a lot of trends going is how do you then take that to the next level of automation?
Okay.
Because we're seeing a lot of people truly bringing their data center as infrastructure as code. That is where I think a lot of trends are going, is how do we bring that same kind of capabilities that have been in the public cloud for a while, for things like Terraform integration.
Yeah.
How do we bring that to the private cloud in your own data center? And that's where we're seeing a lot of our users turn into, that they don't even go to a UI anymore. Everything they have is, whether it's Terraform or Python or some other programming language, where they're writing code and how they want the outcomes to achieve, like we talked about with the intent-based design, on what are the outcomes they want, and then everything is stored as infrastructure as code, is everything about their network is stored as that way. So I think there's still a lot of aspects around programming and automation that we can continue to learn and evolve on, as well as staying up to date with what is going on with AI and how we can use that and how do you leverage that.
All right, AI in the data center, it's happening now. We're seeing not just be slapped on, but actually we're building it from the ground up to focus on AI. We're not just getting in the CLI and we're in the weeds. We're now able to be freed up to think about what our network is doing, how we can actually provide services to our people that we're working for and with. Kyle just walked us through a ton of stuff. Thank you so much for taking the time to do this and helping us learn about what's coming. Where can they find you?
Yeah, so I am active out on LinkedIn, so find me out on LinkedIn. We just did some recent post announcement and blog posts out there on some of the new stuff coming out, especially around the predictive stuff that we talked a lot about today. So reach out, connect with me. I'd love to hear feedback on what people are doing out there in the industry and where Juniper can come in and help revolutionize the operations.
Awesome. Well, that's all we got. We'll catch you guys next time.
Yep, thank you.